Hi everybody, today we are going to be talking about adding polynomials together. But first, before we get to that, we have to start off by talking about classifying our polynomials. And so we're going to do that in two different ways. The first, we are going to classify our polynomials by the number of terms there are in our polynomials. And the first thing that we definitely want to always check is that we simplify before we classify. Simplify meaning combining like terms. So if you see two terms that are of the same type, you combine them, and we will talk about that some more here in a minute. The first type is called a monomial. And if you think about that word mon or mono means one, so it's something with just one term. So examples of that could be the number 3. There's just one piece, one term. You could have x squared. So something with an exponent would be great. There's not going to be any kind of addition or subtraction with a monomial, but you could have multiplication. So we could see something like 4xy. There's multiplying happening with between the 4 and the x and the x and the y, so that works. We could do something a little more complicated like 3x squared y to the power of 3. We could do anything like that that has no addition or subtraction. 2x, something simple like that as well. Each one of these is called a monomial. Each individual one is a monomial. Then we have something called polynomials. Poly meaning many. That poly part. So a polynomial can be made up of multiple terms. A monomial is also considered a polynomial. It's under the umbrella. Polynomial is kind of the big umbrella term for all of these. And a monomial can count into that, or it can be something made up of multiple monomials that have addition or subtraction happening, the sum or the difference. So we could see addition or subtraction happening. So examples of these are going to be multi-pieces. So we could say x squared plus 3. There are two separate pieces. There's the x squared, and then there's the 3. Those are two separate pieces connected by addition, and so that is a polynomial. We could also do something like 4x squared plus 2x minus 1. We could make this have as many pieces as we would like. We could also just do something like 7x squared. That's a monomial, but still counts as a polynomial. We could say 5xy minus 2x plus 7y squared minus 1. That's got multiple pieces in it. Again, there's not really any limit to the number of pieces. You could have 7 terms, you could have 8 terms, but we don't need to sit and write a whole bunch of examples. Now, once we have that polynomial, we can classify it just a little more specifically. We already talked about monomials having one term, so one piece. But as we go through, we could also have a binomial meaning 2 terms, so there are 2 separate pieces. Or we could have a trinomial, meaning 3 terms, so there are 3 separate pieces separated by addition and subtraction signs. Or we could have a polynomial, which is what we call it if there are 4 or more terms. So we're not going to have a name for if it has 5, 6, 7, 8, 9, 10 terms. We're just going to call it a polynomial. So that one has 4 or more pieces to it or more terms. Now, as I said earlier, we always want to simplify before we classify, and that's going to be true every single time. We're going to check. We're going to simplify or combine like terms. That's what that means. To see if we have anything to simplify or combine. So if we look at A here, it says 3x squared plus 2y plus z. None of these have the same variables or same exponents to combine together. So that one we will leave as is. But if we look at B, it says 2x squared minus 9 plus 6. That minus 9 plus 6 can be combined. Those are 2 like terms. And so I'm going to rewrite this. We have 2x squared, and then -9 plus 6 gives us a -3. So we went from 3 pieces to actually 2 pieces. So that is our most simplified version. And if we look at the rest, we have 4x to the power of 3 minus 7x squared. Even though these are both x's with exponents, they are not the same exponent. So we can't add them together. It's like adding x's and y together. We can't do that. Plus 3x plus 10, so that stays as is. And then 3x to the power of 3. So we're going to go through and classify each one of these based on the number of terms. So we have 3x squared, 2y, and z for a. So that makes this a trinomial. It's got 3 pieces. And then we have 2x to the power of 3 and that -3. There's 2 pieces, so that makes this a binomial. For c, we have 4x to the cubed, or 4x to the power of 3, -7x squared, 3x, and 10. That's 4 or more pieces. That is just a polynomial. And then our last one just has 1 piece, so that's a monomial. Okay? So that's classifying by how many pieces there are, how many terms, and then we are going to classify by the degree. So classifying by the degree has to do with the exponents, or the little numbers, So the degree of a monomial, the degree of one term, is based off of the sum. So we're going to add the exponents of the variables. We are going to add the little numbers on the letters. The little numbers on the letters. I don't care about the big numbers at all. If you have a big number, that is what we call a constant. And it's going to have a degree of 0 no matter what for this purpose. So all I'm looking for is the little numbers on the letters. So if I look at my first example, it says 3x squared. That 2 is going to be our degree. So it has a degree of 2. Our next example says 4x to the power of 3 and y to the power of 2. I'm going to take that 3 and 2, and it says the sum of the exponents. So we are going to add those together. 3 plus 2 is 5. So our degree here is 5. Then we have 5x to the power of 3, y to the power of 2, z. That z doesn't have a little number. Anytime we see a letter without a number, it's automatically going to be 1. So if you see a letter without a number, it is automatically 1. So we are going to take that 3 plus 2 plus 1, and that gives us 6. So this has a degree of 6. And then lastly, we have just a number. Its degree is going to be 0. Now the degree of a polynomial is the degree, what we would call the degree of the entire figure. And that's not all of the degrees added together. It's the degree of the term with the greatest degree. So again, we're going to go through, I'm going to write the degrees below each one. So we have 3x squared, that has a degree of 2. We have 4x cubed, y squared, that has a degree, remember we add those together, of 5. And then we have 5x to the power of 3, y to the power of 2, z to the power of 1. And so that has a degree of 6. And then that 6 by itself has a degree of 0. So the largest degree is that 6. And so that's the degree of the polynomial. So if I said, what is the degree of this expression? I would say 6.